Today we are going to show you a proof of the sum formulas for sine and cosine. First we have to create our sliders, and we can do so by plotting a point and then translating that point to the right. And then we can create a ray, drop a point on that ray, and hide the ray. And then if we connect those 2 points, you can see we have a slider. And then we have to do the same thing again to create our second slider. Hide the ray. Connect the points, and we have our second slider. Now we have to measure our x-coordinates and calculate the difference. So we can do measure abscisca and then calculate the difference. And do the same with the second slider. Alright, now we have to create a parameter because we want to create these sliders for angles, not for distances. So we can go to number, new parameter, do value 10 and select angle. And then we can take that parameter and multiply it by our distances to get our angles of rotation. So number, calculate, take the parameter, multiply it by the first one, and do the same thing with the second one. And then we can hide our evidence.
Okay, so next we need to create our circle. So we need to drop a point and then translate that point horizontally, and then create our ray. Next, create our circle with the center of that original point, and then leaving the other one on that ray. And then we can hide what we don't need. Next, we need to mark our angle of rotation, and then this is the point which we are rotating by the first angle of rotation. So we do transform, rotate, and then that by our marked angle, and then hit rotate. Then we need to rotate this point that we just rotated about the center by our second angle of rotation. That one. So now we just need to create our basic triangle. So we're going to construct a line segment here, which is our radius, and then construct that. Next, we need to construct a perpendicular from this point to this line. So construct perpendicular line and connect that, and we can make this a line segment, and we can hide this, and then we can check to make sure that our angle of rotation sliders work, and they do.
So now we're going to put in our radius, put it back in.
That's okay.
Not like that though. Make our circle bigger so we can see things a little bit better. And now we're going to start labeling. So let's start with this actually. Let's start with our radius, which is got a value of 1. Then we have our angle that we are going to label alpha. Oh. So with this angle alpha and our radius of 1, the opposite side then becomes the sine of alpha. Label that here. Meaning that our adjacent side is then cosine of alpha. Uh-oh. Picked up the wrong piece there. And now this piece is our cosine of alpha. And we're going to want to get rid of this label here. Check this all works out. Looks pretty. It does. So now we're going to move on. Let's move that over a little bit. Now we're going to drop some perpendicular lines in. One more for good measure. All right, we have a ton more to mark. We have a bunch of right triangles here. Why isn't? Oh, I haven't put points on. So we have a bunch of right angles by construction. Here we have another angle that we're going to label beta. It's a little cluttered. We're going to get rid of that. Label this C. Final angle? No, not our final. There we go. What else do we have? Oh. And then we have C here again, one last time. And this angle is beta. Not like that.
Now we have a little bit more of a construction to make. We are going to see if we can actually get a couple of triangles set up. The triangles of interest, of course, the original one with the radius of 1, and then we're looking at the smaller triangle here. So let's see if we can actually get that a different color to be able to distinguish that. And then we're going to see if we can create a interior for the triangle here. And once you collect those 3 points, we can construct triangle interior. Another triangle of interest is the next one right here. And these are of interest because they're both similar triangles. The angle here, C, is the same as the angle on the opposite side, right there. And because of this being a right triangle, this also being a right triangle, if this is C, then the angle on the outside has to be B. So let's see if we can actually So that's C, and the angle on the other side, right here, should be angle B, or beta. So when we're trying to figure out what the cosine of actually what the sine of angle alpha plus beta, I'm looking at the segment all the way from, let's see, maybe we can actually label these points, F to H. So all the way from F double to H. So now, in order for me to look at that, I can actually think of it a little differently. First of all, let's see if we can actually identify this side here. Since the side here is the same as the sine of angle beta, however, that is not necessarily just sine, it's also sine of angle beta, and it's truncated by the cosine of angle alpha. So that should be equal to cosine alpha times sine beta for this line here. On the other side, for all the way from here to here, let's see if we can actually create a line through that. This line is the cosine of angle beta truncated by cosine alpha. So that is cosine beta truncated by cosine alpha. All right. In order for us, like I said again, we are trying to find what the line, or we're trying to figure out the cosine, the sine of alpha plus beta, which is the line from this point to this point. And we can think of that as being made of two different lines. The line from here to H, and then from there to F double prime. However, this side here seems to be the same as cosine alpha plus sine beta. So if I wanted to think about sine of alpha plus beta would be equal to, so then that means that sine alpha plus beta would be equal to cosine alpha sine beta plus the cosine beta sine alpha.
Now that we have found the sine of alpha plus beta, we want to find the cosine of alpha plus beta, which is the length from E to H. We already know that the length of E to K is cosine beta times the cosine of alpha. If we look at the gray triangle, the missing side is sine beta scaled down by the hypotenuse sine alpha. So we can label J to I as sine of alpha times the sine of beta. And now, by the constriction of our parallel lines, we also know that the segment H to K is sine alpha times the sine of beta. So now we can say that the cosine of alpha plus beta is equal to the cosine beta times the cosine of alpha minus the sine of alpha times the sine of beta.